Good morning, everyone. This is Jagdish, Assistant Professor of EC Department, SNS College of Technology, Coimbatore. Today, we are going to discuss about the topic effects of parasitic capacitance. This topic comes under the unit W band gap devices and their applications in real world. Come, let's get into the topic. What is parasitic capacitance? Parasitic capacitance is a phenomenon in which elements in a circuit behave like a capacitor when they are not physically a capacitor. It is easier to comprehend the idea of parasitic capacitance if you revisit the basics of capacitor. A capacitor is made up of two conductive elements separated by insulating material. When both conductors are driven by differential potential, charge built up across them. Charge that builds up is expressed in capacitance by the formula C equal to Q by V, where Q is the charge and V is the voltage. Physical capacitors are constructed on the above mentioned principle to intentionally create a storage of electric charge in a circuit. However, capacitance may also exist between elements of a circuit so long as the elements are within the required distance of to form the charge between them. The unintended capacitance formed in a circuit is known as the parasitic capacitance. Parasitic capacitance can develop between two conductors at a conductor and an adjacent ground plane, or any two elements that fulfill the criteria to build up charges. The probability of parasitic capacitance is greatest when parts of the circuit are near to each other and of two different voltage levels. Capacitance could develop between two conductors in a circuit. When conductors are placed on a different potential level, the charge built up is determined by the following equation, that is C equal to summation into A by D. The parasitic capacitance effect is prominent in high frequency boards when traces are closely placed. This effect is completely unwanted and affects the functionality of the device. It leads to problems like crosstalk, EMI, and signal integrity. Parasitic capacitance changes the unintended output from the circuit or device. In amplifier circuits with extended frequency response, parasitic capacitance between the output and input can act as a feedback path, causing the circuit to oscillate at high frequency. Parasitic capacitance is likely to present in the circuit, and for low frequency designs, it is unlikely to cause any major issues. However, parasitic capacitance can be a major problem when in a high speed design. As the frequency increases, the behavior of the capacitor changes and it eventually acts as a short circuit. You can expect the same for the parasitic capacitance when high speed signals are running through one of the elements. In an amplifier design, a parasitic capacitance that forms between the input and output result in unwanted feedback. The usually open circuit path becomes a conductive when operating at high frequency and causes undesirable oscillation or a parasitic oscillation in the amplifier circuit. Parasitic capacitance can be troublesome for two adjacent conductors. When one of the conductors carries a high frequency signal, it can introduce crosstalk to the other conductor. Higher parasitic capacitance leads to higher EMI noise. So here this is the how to remove the parasitic capacitance. So the PCB design board is shown over here. Removing the inner layer ground plane helps reduce the parasitic capacitance, and the circuit density continues to increase in many PCB designs. It is impossible for the parasitic capacitance. You can, however, reduce its effect by applying these different strategies. Effects of parasitic capacitance, high frequency design complexity. First thing, increase clearance between conductors. If possible, allow for higher clearance between traces in the design. Capacitance is inversely proportional to the distance between the conductors. A larger clearance will reduce the parasitic capacitance and effects like cross coupling. Use ground plane appropriately. While an inner layer ground plane is recommended for reducing stray inductance, EMI and heat dissipation, keep in mind that it could also increase the parasitic capacitance. Reduce vias. Vias are useful when building a compact PCB, but having too many of them can introduce significant parasitic capacitance. Use vias sparingly and try to avoid any on high speed traces. Low parasitic capacitance design is easier with the right PCB software. OrCAD PCB Designer allows you to set design rules and tools to keep parasitic capacitance at obeying the high-end circuit board design. Thank you.